How much electrical energy will be spent when the current flows through a resistor? All right, so this electrical energy, like spent per unit time, we call it electrical power. We use the symbol P to stand for that, and its unit is watts. So the power is the energy, electrical energy over a certain period of time. So what's the energy here? The energy here is the electrical energy. So which means it's like the change in electrical potential energy. Electric potential energy, as we learned in electrostatics, electric potential energy is simply the charge filling the potential difference. Right? The charge filling the potential, Q times V. So V, which is the potential difference or potential like before in the electrostatic, but in the unit of circuit, this potential difference we also call it voltage. So this V is the voltage V in the circuit as well. Then what is Q over T? Q over T is how much charge flowed through per unit time. So that's basically the current. So what's the power? Power is nothing but I times V. Okay. So how much current do you have and how much voltage is carried by each current? P equals to IV. So say if I want to understand how much power, electrical power is costed or spent over resistance, then I can simply find out the current going through this resistor and the voltage across it, multiply them, and then I get the power. Or I can just combine this P equals to IV, combine it with the Ohm's law, V equals to IR. Say if I don't know how much current is flowing through the resistor, but I know the voltage and I know the resistor, I know the voltage and the resistance, then I can just simply replace my I with V over R. Then instead of P equals IV, I could have P equals to V squared over R. And similarly, if I don't know my voltage drop, I only know the current flowing through the resistor, then I can just simply replace V with IR, then I'll get my power equals to I squared R. Yeah, so don't treat this through like a three different relationship or three different equations. They're really just a combination of like utilizing the relationship V equals to IR and use that to find the power. So let's take a look at this example. What is the power of the light bulb? So this light bulb has a voltage 10 volt. It has a resistance 2 ohms. So if we want to figure out the power, we want to know how much current is going through and how much voltage is carried by this current. So P equals to IV. But in this case, we know V is 10 volt because the voltage drop across the light bulb is 10. But I don't know what's the current. So what should we do here? If you don't know the current, but we know the resistance, then we can use the V and R to figure out my current. We'll do V over R. So this is because of an Ohm's law. Okay, and now I just need to put in all the numbers and then get the answer. So it's gonna be 50 watts for this light bulb.